Well, hey, on behalf of the guys on the screen, welcome aboard, everybody. Our club's little excursion into the comets and constellations and cutting edge cosmology we call the SBAU Astro Hour. My name's Ronnie Heron, and each and every Monday morning, 11 o'clock, the gentleman and I gather on the screen from the Santa Barbara Astronomical Unit and Astrophysics Club. We go over the latest in discoveries and theories and photos, and we have them all doing it. We've got 5 years on YouTube behind us doing this into our sixth year. This will be our 270th episode of the Astro Hour. Covers the week of this Monday morning. We're at April 27th into the new month of May, May 3rd, Sunday, 26th. You are invited to come join us. First Friday is this weekend, our monthly general meeting. A week later, second Saturday night star party outdoors next to Palmer Observatory and the beautiful Santa Barbara Museum of Natural History. Read all about us on sbau.org, and here's what we're talking about this week. Got a full moon near midday Friday, and our timeline of meteor showers for the year 26, including this headline from last Wednesday morning's New York Times. People have been reporting seeing far more meteors than usual this spring. Scientists attribute it to the natural ebb and flow of the cosmos, not aliens. So you can sleep better tonight. A new little moon for Doug, the name we've given our proctological seventh planet. It's a tiny little satellite, so it gets a phone number, not a name. There's a big current, a big bad one generated inside the sun recently. We're talking major magnetic fields this week. A couple of colossal X-class flares on Friday. And X-rays, which are very powerful photons, but they're coming from a star in Cassiopeia with gamma in its name, the powerful far right end of the electronic never mind, the spectrum. I got another comet or two to talk about, a new one called Temple 2, and we'll give an update on pan-stars, and a nice new Milky Way neighbor discovered in 1988 called, you ready for this, the Black Widow Pulsar. Let's meet the Brain Trust. Our man in charge, captain of the program, who's their club president, becomes a professor from Broida Hall on astronomy Monday morning. Good morning, Jerry Wilson.
Good morning, and good morning to Joyce and to Robot Tree, aka Riley, and to my grandson Calvin.
Did I hear you say robot trees?
Yep, you did.
Okay, well, we know and love your first lady, Pat Forgy. He's married to a Pat, and so is our outreach guy, a man who occasionally has to pull the plug on Astronomy Day, and doggone, he was right in foreseeing exactly what happened Saturday out at Camino Real. Chuck McPartland, good morning.
Yeah, good call.
Okay, the speedy
that wouldn't have
recovery.
been much fun.
Well, I guess on Sunday, well, we'll talk to the other guys who were there for Sunday's version. Was there a Saturday version at the Museum of Astronomy Day? Because
No, they don't do that anymore, Ron.
Oh, okay, but Sunday you didn't have the same problem, did you, Tim Crawford?
No, it was pretty nice. We had
It was beautiful once the clouds cleared, right, Tim?
yeah. Tommy
Well,
was in the observatory showing him the white light, and it was in spite of all the weather, we got 58 people.
Yeah, it's pretty
Is
good.
that right? And you're telling me there's a lot of international touristas showing up in our town from everywhere.
It's amazing. It's amazing how many foreigners come through.
Yeah, there was a special event, Ronnie, yesterday at the museum that kicked in at 3, and it kind of chopped some of our folks coming through. Anyway, I think we could have had a lot more, but there was a special event, and
well, I'm glad we can see you, Tom Whittemore, at some events, because we rarely see you. You do a great newsletter, and you've been doing that forever. You're just never at the general meeting, but so I've seen you there, I guess, at some time.
Okay.
We'll be in Fleischman this coming Friday night. Tom is a former instructor at Westmont, married to the lovely Maureen. Tim, to his left on my screen, is married to Karen and is preparing a dynamite program to be one of our 2 in-house member speakers in December. I assume you're working on that, Tim Crawford.
A bit.
Okay.
I don't know what I'm going to do. I'm still undecided.
I think, how about logarithms, Tim?
Oh boy. No.
How about plasma RS?
Yeah, yeah. A plasma, that'd be good. It would be a 1 minute lecture.
I think most of the matter in the universe is in a plasmatic stage. I really do. The planets are much smaller. But then, of course, there are those huge nebulae that are pretty solid, and nevertheless. Let's do the cartoons of the week. President Jerry always forwards us 5 or 6 incredible. Some of them are thought provokers. Some of them need explanation, but mostly we can figure these out. There's Isaac Newton, and is this the Isaac Newton?
Yeah.
Pretty good.
Yeah, yeah.
What was the name of that album? Pink
Far Side
Floyd,
of the Moon. Far Side of the Moon.
Far Side of the Moon.
Dark
Okay,
Side of the Moon.
Oh, Dark Side. Dark Side.
Yeah.
and it used this very picture that we're seeing
No.
right there. I'll be
It just
damned.
had just the beam of white, a prism, and then the spectrum. on
Yeah.
the cover.
Yeah.
Well, that's not from his Principia book? What was his major
Principia
contribution?
Mathematica.
Principia. Principia Mathematica.
It was actually. He talked about white light being made of all the colors.
Mhm.
Okay, and this was in between inventing calculus. It's a
And
great
of course, Ron, you know the definition of a prism, don't you?
A prism. No, no.
Yeah.
That's where they send criminals.
Well, I used to be a prisoner. Okay, Fred and Wilma are having that doesn't look like their kitchen I saw with rock, but nevertheless, it's the Flintstones. Anybody want to take this? Tim
Yeah.
McCrawford?
Yeah, this is a good one for me. This is my wife telling me, you said no more telescopes. And I said, oh no, more telescopes.
Okay.
See,
I don't know why they put them in.
after the number of telescopes you have reach a critical level, your wife or your spouse can't tell if you bring a new one in or not.
Yeah. And speaking of lots of telescopes, I think Isla said it best. She said it must be spring cleaning because I think we've had 4 or 5 offers for donated telescopes in the last 2 weeks.
Oh yeah.
Ooh.
So they would have been made to Tom Totten, our telescope guy, our
Yep.
webmaster.
Well, yeah, they come to various other people and get shunted over to Tom.
Well, I followed Hanna-Barbera for years, and I never saw any telescopes in a Flintstone cartoon. Here we go. We're on the moon, right? Are these the tail end of
Yeah.
our
Those are weird. Weird.
Apollo.
This is weird.
Chuck, why don't you guide us through these two
All
spots?
right, you got your NASA astronaut and a lunar lander, and he's standing there on the moon. And he says, "Houston, we have a problem." And then you get the view that he's seeing, and you see a crashed lander and a dinosaur skeleton and a dinosaur flag planted on the moon. Who said they didn't have a space program?
Yeah, yeah.
I first thought it was the cow that jumped over the moon, what was left of it, but it was a dinosaur.
No, there's a joke about that too.
All right, how about Tom Whittemore explaining us as he would do
This
his
is
suit
this
on
is the one I
Westland?
told you, Jerry.
Uh-oh.
Tom?
It just
Okay,
says aliens be like. They kill each other over arguments about what happens when they die and fail to see the irony in it.
boy, oh boy.
Yeah,
bunch of nuclear
that one
bombs
isn't so
going off.
funny.
All right, Mr. President, you're going to have to introduce us to the man with the cat since you
This
have
is a picture of Erwin Schrödinger, and it says Schrödinger's straight, open and closed at the same time.
Ooh,
Pretty good.
there's a blockade from our side, and
Yeah.
okay. Who wants to take this one? Chuck? Gonna have to enlarge it.
This is the new one.
Yeah.
Oh, the
Okay.
Earth is talking to the sun. Go ahead, explain that to us.
All right. So the sun is there saying, "Why are you so happy lately?" And the Earth says, "Hey, son, it was Earth Day recently. It's once a year, and they named it after me. So I guess you could say I'm rather important." And the sun says, "Oh, okay, cool. Hey, Earth, what day is it again today?" And then the Earth says, "Oh, you're so confused sometimes. It's Sunday."
Okay, somebody's into the mushrooms making these cartoons. Okay, we're inside a large observatory, Mr. Prez. What's going on?
Well, these aliens are bringing a policeman into the observatory. It says, "That's them, officer. They've been peering in our windows for years."
That's a good one.
Yep, peeping toms from space.
Yeah. Ooh.
Oh, Here you go, Tom. What a more perfect for you. You do a finding, Waldo. Have you ever seen those? You have books of those laying on your coffee table?
No, I don't know anything about it.
I
Sorry.
just got a big book of Where's Waldo for my
Okay.
grandson. And
Well,
the
they're
idea
awesome.
is
They'll
there's these
drive you.
very intricate pictures, and somewhere in it is a guy named Waldo that's usually wearing a striped hat or something.
I
He's in
really
the upper
like this
right.
one. It's way on the upper right somewhere up there. I found it once. I think there's
Right
a
there.
yeah,
A little more to the center and a little more up. Okay, no, up, no, more to the right. There he is.
right there.
Right there.
Yep.
Oh yeah, there he is, the two eyes and the
Yep. Boy, it was hard. I went through that like 2 times magnified before I
yeah,
saw
there
that.
he is right there.
Yeah.
Okay.
Oh, I see. Wow.
Was that where Planet 9 is in the other picture in the upper right?
Yeah.
That's one
Where
of the
would
deep.
that put? That'd put it right about here.
Yeah. Yeah.
It used to be the subject of Mike Brown's speech. He gave up on Pluto. Nobody wants him to talk about that, but
Hmm.
he would be talking about Planet Nine. It'd be Vera Rubin telescope this year if we can get him in the fall, but it doesn't look like I'm going to. Okay. Got another one?
I don't know. Let me find out where the advancement is. Oh no, that's the last one.
That's it.
Okay. Yeah. Good stuff. Gets us in a light mood so we can go to the serious stuff.
Uh-huh.
Comets are us. Comets and cosmology, cutting edge stuff, folks, and we have a ball talking about it. I get to show off my new hat. Meteor showers,
Hmm.
2026.
We
There's
are
always
just,
one, isn't
what
there?
is today? It's the 27th. Last week, about this time, the Lyrids peaked. Did anyone catch any Lyrid meteors?
No.
No.
According to
Okay,
the New
well,
York Times, they're seeing more and more these days, but
Well, those are sporadics, but yeah.
yes.
Hmm.
So on May next month, in a short few days, I guess about a week, we'll see the Eta Aquariids, which is similar to the Lyrids in its projected amount of 10 meteors per hour. And you remember that we always tend to look at these meteor showers between midnight and dawn, because that's when we're on the leading edge of the earth and we're running into them. The same as your car windshield runs into raindrops when you're in a rainstorm.
And the
really,
Aquarids are southerly,
These
not
ones?
as good as the Lyrids.
Okay.
well, speaking of raindrops, last night's big PBS show, what do they call their science show? Nova,
Mm-hmm.
was called Rain Bombs. I
Hmm.
think I was hit by one of those once.
What's
where
called what?
Rain bombs.
Rain bombs. Oh, that, yeah.
Concentrated rain that will
Yeah, they used to be called microcells.
really. Well, I can recall being hit once by a rain so fast or so strong that my windshield wipers wouldn't handle it. So,
Oh
Yeah.
yeah.
Yeah, I've been hit by that too.
wow.
If you're in a plane and it's landing when that happens, the plane
Yeah.
usually is pushed into the ground and crashes.
Ooh.
So
We
they
had a
have
doctor that showed up from bought a brand new car, and he was an emergency room doctor that would travel around. He went down to Texas with a brand new car and got hit by a hailstorm,
oh,
size
Wow.
of baseballs. He came back, his new car looked like looked like it was about 25 years old,
it's all
all
dented.
dented.
Yeah,
Well,
my wife is from Kansas and she's seen those heavy meteor or not meteor, but hailstorms before. And they usually, car dealerships have a sale on hail damaged cars.
and she
God,
brought her dog Toto with her. You guys killed a witch with that house?
Yeah. Occasionally we see hail here.
I'll kind of tell you, hail is awesome.
Mhm.
Analyze that.
Okay, now this is a picture of
Go ahead and say it. Uranus.
Uranus.
Yes, yes.
Uranus. That's better. Yeah.
Not much better, but better.
yeah, one cartoon years ago had it labeled as they showed the orbits of the planets out from the sun, and Uranus was labeled Doug.
Doug.
So this is Doug, and it has a new moon. It doesn't have a name yet, right there. This is a picture with the near IR camera from James Webb Space Telescope.
Okay.
So near IR is around, but just out of the visible band at the start of the IR band. So it's around 1 micron to 2 to 3 microns in wavelength.
Okay.
There's the well-known Miranda, which for some reason my planetarium software, the Sky 6, keeps putting random asteroids and naming them Miranda. I've got something set wrong in it somewhere.
How many moons does Uranus have?
29
Wow.
29.
Now,
now. Yeah.
Yeah.
And Miranda is a Shakespeare character?
A lot, almost all of those you see there are Shakespeare characters, if
Are
not
they
all.
really?
Right. Mm-hmm.
yeah,
Wow.
Puck, he was in Midsummer Night's Dream,
Oh, Puck, of course.
Juliet, Cupid,
Yeah.
Desdemona.
Desdemona shows up in a Verdi opera.
Yeah.
But is this new satellite another Phobos, or the ones that go around Mars are nothing but little asteroids? This small?
I don't know where it came from. Some of these may be captured. There's enough objects around here. You can't, two objects floating in space that just happen to be in the same space, they cannot capture each other. One of them has to lose a lot of energy to go into orbit around the other one. So there needs to be a third body or several other bodies that can pick up that extra momentum and get flung off into space in order for it to capture one. With these numbers of small and medium-sized objects around, that could easily happen. Another body could pick up that momentum. Just like the collision, the momentum has to be conserved.
And this is a pretty small moon.
Yeah.
Yes, it is.
And Ron, you see that one moon upper top near the top?
Yeah.
Can you say that backwards?
Damn.
Bam.
Is that a Shakespeare?
Bam.
Who was Mab? Or is that what it? Yeah, who was Mab in Shakespeare? What play was that?
I don't know.
Doesn't ring a bell for me.
No.
Looks like a matrix element, M sub AB.
Yeah.
Maybe a
you
parody of
Mad
Mad Magazine.
in some of these Arthurian legends, I think.
Uh-huh.
Well, how did we see this? How did we find it? Certainly not with a telescope earthbound, I would think.
Yeah.
It's with the Webb telescope.
It's the
the
Webb
Webb
telescope.
telescope.
Webb telescope.
Takes that.
You get a real nice view of the Uranus ring system here.
Yeah, and Ron, you can tell it's probably the James Webb when you look at the diffraction patterns on Puck.
Right?
Oh, yeah.
See that six stars or Miranda too.
You can also tell from the title up here.
Yeah.
Right.
Oh, okay. Amazing.
Okay. We've seen some action from the sun.
Ooh, back home
lately.
here.
And I get the feeling from talking to the general public that the public thinks the sun is like a big ball, like just a really hot planet. And it has a magnetic field, like the Earth has a magnetic field. But that's not really the case. The sun, the dominant structure on the sun, what we see on the sun is all due to the magnetic field lines. And the magnetic field lines, the sun, this represents the rotation of the sun here. And like the Earth, there is a dynamo in the sun that makes a magnetic field. And even though the magnetic field here is drawn ending, they don't end. Every magnetic field line is a continuous loop. There are never, like electrical fields start on a negative charge and end on a positive charge. They are, or the other way around, I guess. These are continuous loops, always loops. And so they can't really break. And I know that you hear about people talking about they break and reattach, and they sort of do, but not really. So as the sun rotates, it's not a solid object. The equator rotates faster. So the parts of the magnetic field that are down here near the equator, those start speeding up and they rotate faster. And so it starts distorting the magnetic field and it keeps pushing it around. And here it shows one that's gone around completely. several times, so it gets all twisted up.
Yeah.
And at an average time, you can get magnetic field lines that are, it's like taking a big ball of rubber bands and trying to crush them into a spherical shape. As you do that, they pop out and they arc all over the place. And you get these complicated structures.
Right.
Where you get things like this, that's a set of sunspots where they come through the surface. The magnetic field lines align these cells. This is a sunspot. Align these cells and cools them off slightly. And that's why they appear to be darker than the other side, than the region around it. Only slightly cooler, but it's still pretty hot.
Yeah, and Ron, the sun rotates faster in the middle than it does on the top and bottom.
Does Jupiter do too? Is its layers around the big red spot faster than the
That's
other
an
layers in
interesting question.
10 hours?
Yeah.
I'm
I
gonna
think
ask
it's
that
not
very
quite as
question.
extreme on Jupiter, but
Yeah, okay.
The thing is that the stuff that rotates faster on Jupiter is not ionized. A magnetic field is due to moving ions, moving charge. So if you're out in space and an electron comes flying by, as the electron passes you, you feel a magnetic field. And then the electron's gone and the magnetic field is gone.
Yeah.
If you are, and since speed is relative, if there's an electron sitting at space and you fly by the electron, then as you pass it, you feel the magnetic field. And when you're past it, the magnetic field is gone. So it's relative motion to you. So these magnetic field lines are produced by microcells, microdynamos in there. And what you see locally and over the whole thing is the vector sum of every magnetic field line or every magnetic source in it. So the magnetic field lines do change. They can appear to, and they are discussed as appearing to break and reconnect, which changes energy. But it's really the microcell. The magnetic field line is the effect of the moving charge. It doesn't determine the moving charge, but it also does. It's like an electron trying to move in a magnetic field feels a force, and it's the force that's applied by the electron making the magnetic field. So the mathematics, it's called magnetohydrodynamics, and it can get pretty hairy. But
Jerry, do the magnetic field lines, do they always emanate from the sunspots?
no, they don't. When magnetic field lines concentrate and go through the surface of the sun, then the sun forms a sunspot. The magnetic field lines determine almost every effect we see.
Okay.
what happens, Tim, is there are these convection cells that you see as the granulation that are coming up from below.
Right.
They're bringing heat. But
Right.
but when you have this concentration of magnetic field lines going in and out like that, it diverts those cells to come out around them. And so that's that plage that you see around the sunspot where it's
Right.
hotter. And then it cools down. It appears cooler in the center where all those field lines are, but it's like 4,000 Kelvin instead of 6,000 Kelvin. So it's
Now, are they dropping down? Are things dropping down where the sunspot is, like a convection cell is the opposite? It's brighter in the center and darker at the outside as it drops
Yes, the
back down.
magnetic field lines will have different polarity. The particles do not go in and out. There's one will be north and one will be primarily south.
Mhm.
But
So there's okay, all right.
now these magnetic field lines here, they look like ISO elevation lines on a topographic map. They are not ISO magnetic fields, field strengths. Where the lines concentrate, where they come together, that's where magnetic fields are stronger. So as
Okay.
you see, they go through here, that's stronger and stronger. Going out here where the lines are individual, those are weaker magnetic field lines.
Now, I've been telling people on Sunday that the sunspots, although they're cooler, they're also probably the strongest magnetic field on the sun.
Yes, that's true.
Okay, good.
Yeah, I think of the field lines, Tim, as like a magnetic bottle. Okay, concentrating and then having charged particles basically spiraling around them, you
Right.
know.
According to your talking points, Jerry, you had a couple of colossal X-class flares released on Friday. Did we get pictures of that?
Oh,
Yeah,
Tim,
we do.
tell them the story, what you saw, we saw yesterday.
Yeah, yesterday when it did clear finally, late in the day, and my scope showed around the sunspot the usual proj where it's a brighter around the sunspot,
And it
but
was
but
amazing.
there was a spot
Mhm.
that what clearly went. It was a hole. It might have been a coronal hole, whatnot, but
Yeah.
it was clearly very, very bright, much brighter than I've ever
And,
seen.
and Tim, where was it pointing?
Oh yeah, yeah.
Or not?
You don't want to
The
know. I
earth.
think it
It was
was
pointing to
Galita.
the earth.
Pretty sure it was pointed at Galita, Ronnie.
Yeah.
Well, do those do they flare up and change the auroras? Make
The
them more intense?
Oh, okay, let's move on to the flares.
yeah, Jerry's
Do
going to
they
get all into this. This is really
they
cool.
affect us, don't they? They didn't affect communication or satellites or anything?
Yes.
Oh,
So
okay.
the sun's magnetic fields and the solar wind pushes out. The sun and us are traveling this way, and the interstellar medium, which is a very low density plasma, is produces a bow shock in front of us because it's pushed away by the sun's heliosphere, which is the solar wind pushing out. And that's due to the magnetic field of the sun. So you'll see bow shocks later on today if we get to it. This is a picture of the sun during the first flare, which came up around here. And this is a picture of the second flare, which also came around here, 2 in a row. And this is the effect of these flares.
Wow.
It turns out that we were just going into the daytime. Let's see, the Earth rotates this way. So we're just going into nighttime as the flare occurred. And this is where the radio interference was, what is it?
Magnetic?
Yeah, it interfered with radio communications here.
Oh, it did. Wow. But no pictures were taken?
We'll get to that.
We just saw the pictures.
Yeah, those were pictures, but I have also got videos.
I mean, a flare can't cover 93 million miles and hit us. Just
Some parts of it cover it in 8 minutes.
Right.
If it did, we wouldn't be here. We would be
No,
very serious.
that's why you see something.
But flares are different from prominences.
Yes.
Yes.
A flare is sort of an explosive beginning of a prominence, you might say.
Yeah.
Let's see.
Yeah. And we saw evidence of a flare, Jerry.
Or an explosive end to a prominence.
Yeah, it was amazing. It really stood out in Tim's little telescope. And in the H alpha scope inside the Palmer purposely overexposed the ball of the sun, but you can see the whiskers on the edges. Oh, look at that.
Oh wow.
Ooh, perfecto.
Isn't that amazing?
So
That's one
this
of them?
flare did not, if it had been right here,
Ooh, that'd be
it would
bad
have had
news.
major effects.
Yeah.
Well, it can, even if it's off more to the edge like that, because the sun's rotating, you get like a spiraling of the
Yes.
magnetic fields, and it can get into one of those channels and still hit us.
Yes, you don't get away scot-free because it's not bore-sighted on you.
Yeah.
So, Jerry, what's the time range on that?
This is an accelerated, I don't think this is in real time,
Okay.
but I don't have a scale for how fast it's sped up.
Yeah. The kind of whiskers we were seeing yesterday, Tim and I, are kind of like the ones up there around 1 o'clock.
Yep.
Huh.
Yep. Yep. And in David's scope, they were all the way around, Jerry.
Yeah, you can get a rough idea of the time range by just watching the rotation of the sun there.
Yeah.
Well,
The sun
General,
rotates about 30 days in its middle, goes around once.
Is science working on tools that might try to figure out if all the other stars out there, or at least the close ones, also have similar magnetic fields and flares and
Yeah,
prominences?
they do, especially red dwarfs.
I was going to say, not anymore, Chuck.
Yeah.
But you know, there are planets that have electromagnetic fields like Earth, and then there's other planets that don't, like Mars. So I wonder if there are stars that don't have any electromagnetism going on. That's
Yeah.
possible.
Stars are plasma, so you're gonna have
Yeah.
that going on.
Yeah, especially if you rotate, you
Yeah.
know.
Now this is the second flare. Looks
Wow,
very
that's
much
more
like the
energetic
first one.
looking.
Same
You'll notice,
place.
you'll notice the sun jumps a little bit.
That's
So anyway,
It's turning like the Earth, east to west.
it goes it's going right to left, you know.
Left to right.
Uh-oh. Well, you know, we have an up and a down and an east and a west on the sun, so you should be able to point out the direction it's turning. I think everything's the same.
Yeah.
All the
Depends on if
planets,
you're standing on your head or not.
Yeah.
except for Uranus. Doug, I think, is on its side.
Yeah,
And Venus.
yeah.
And Venus, that's true. You're right. Venus goes backwards.
Yeah.
Its day is longer than its year somehow, I swear. It's just fascinating. That's why I love this.
Now there is an X-ray source that has been found in the form of Gamma Cassiopeia, which is Gamma Cassiopeia right there.
Oh, we're
It's
not
that-
seeing your.
Wait, we don't see it, Jerry. Are you sharing?
Oh, no, you're right.
Okay.
Called gamma, but it's X-rays. They're both in the
No,
and
the name of the star is Gamma. You know, they did
Gamma.
Alpha, Beta, Gamma, Delta.
Do you see it now?
So it's probably
No.
the third
not
brightest,
yet.
Ron. It's probably the third brightest star in that constellation.
But gamma is not used in reference to the very powerful photon.
It is, but it has nothing to do with the name of the star.
No,
Right.
it's just that letter of the Greek alphabet. Alpha, beta,
I see.
gamma.
Delta.
Yeah.
Which is actually more powerful on the spectrum, gammas or X-rays? Gammas are the
Gammas.
ultimate, aren't
Hey,
they?
gammas.
Gammas. So you'll never have a gamma ray detector in your dentist's office. Thank God, it'll be an X-ray machine.
You could have a Gampal ray, though.
Anyway, this is the morning sky, probably right around dawn.
Did you do a stop share, Jerry? It's still not up.
Oh,
We don't see it.
okay.
I hope you don't have to disengage again, Mr. President.
Okay.
Maybe it's-
Here we go.
There we go.
Okay, so it's the middle, the star in the middle W.
Mm-hmm.
So I don't know, these extra lines are annoying.
Huh.
Anyway, what is happening is at
Like
first
one of your
mystery.
cartoons.
This is it's 550 light years away. It's a B-type star. And so it is,
Heavy on the ultraviolet.
it's what?
Heavy on the ultraviolet. It's purple. It's violet colored.
No, this is a drawing. And
Oh,
this
just a
is,
drawing. Okay.
and all colors, you know, in astronomy, pictures are chosen by the author or the artist.
Well, we know Webb deals in reds, infrareds, and then the other end of the spectrum is ultraviolet, which is hotter as far as stars go. And
So what's happening here is that there is, this is a neutron star, not a neutron star, excuse me. This is a shedding material, and it's putting the material on the smaller companion, which is quite close. And the smaller companion is has a very strong magnetic field, and it's bringing material from this disk going up to the poles like it would if we were showered with a flare and it's producing auroras here on whatever this star does. You wouldn't want to be there.
so it's a magnetar.
No.
It's a magnetic white dwarf. I don't think
Oh,
it's not officially strong enough to be
A magnetar.
a magnetar. Magnetars are absolutely incredibly high magnetic field.
Well, what happens to us if we got close to a magnetar? All the blood with its iron gets sucked out of our bodies? Is that
Not, it would be worse than that. At the magnetic field levels that are in a magnetar, every atom in your body would no longer be spherically symmetric. They would all look like spindles. They would be stretched out. Bonds that you are used to and know and love would not be able to exist. It would change a lot of the physical properties of your body just
Well,
from the
there-
magnetic effects.
there goes that as a vacation destination?
Yeah.
You'll see a movie someday about it.
But it would still be attractive.
Oh yeah, gravity is still there.
Yeah.
Well, I've often wondered if it might have electrically magnetized balls going around it, planets made of metal that are simply attracted by the magnetism. But
Well, strangely enough, a metal, hydrogen is a metal, although not recognized by astronomy. Because if you take a bunch of atoms and you bring them close together so they can bond to each other and they form a solid, then hydrogen has one electron around it, and that orbital can contain two. So when the solid makes a band, that band is half full and half empty. So that defines a metal. So solid hydrogen is metallic and possibly superconducting. We've never made one, so we don't really know, but it's projected to be a component in Jupiter's makeup.
Holy cow, this is going to be another one, Jerry, I'm going to have to ask about. This is like plasma to me.
It is.
well,
Okay.
doesn't the periodic table of elements line up the elements that are alike? Like hydrogen would be at the top, number one. It's a gas, and down
Yeah.
would be
No,
neon.
it is a gas, but it's a partially complete band. It's got an empty electron band. So if you made a metal out of it by bringing all the atoms together, the hydrogen atoms would feel their nearest neighbor, and you can't have two electrons, fermions, occupy the same energy level. So they move a slight offset in their electron energy level, and that's the start of what we call energy bands in solid. And a band that is half full is a metallic band. A band that is completely full is an insulator, because you can't get the electrons to flow in it. But in the half-filled band, the electron flows throughout the material. It's not localized. Now we have a comet coming through here.
Aha.
Not a terribly bright one, but we're going to take a little aside because it goes right through our field of view. This is in very faint letters. They, for example, here's April 20, here's April 26, 25, and here's
Oh, I
April
gotcha.
30. So 25, 26, 27. So right about here is where this comet is right now, Comet Temple. It's in Sagittarius, which you just heard a plug for at the beginning of our show,
Right.
Tom.
Yeah, yeah. It's
And
early
it
morning
has-
object.
what's that?
Early morning object.
Yeah, early morning object.
And there's M11 up there, so it's between the teapot and the wild duck.
Yes,
I believe you called it Temple 2. Is there a Temple 1?
there is a Temple one.
Oh. And it's Tempel, meaning somebody's name, I guess.
Yep.
Yes. But of note, we pass by NGC 6712, which is a globular cluster, and an interesting globular cluster.
Hmm.
This is the characteristic field of view of Hubble, the full field, the wide field camera. And this shows the core of that cluster. That it's really quite a dense core. And inside the core of the cluster, it has a pulsar. And so you're getting periodic waves from this thing. And that's because
Is this the Black Widow?
yeah, we're getting to the Black Widow.
Ah,
This is things that can happen to a neutron star. You can have it become a magnetar with very strong magnetic field lines, which is due to the rotation of the star. You can have a pulsar, which is a highly rotating star with polar beams of radiation coming out. And you can have a magnetar pulsar. There are now 6 known neutron stars that are both pulsars and magnetars.
A question for you, Jerry.
Yeah.
With the pulsars, are they if they're a faster spinning star, is that going to produce this effect where the poles have this emitting this large radiation
Yes.
that we see?
Yes. It's like a crowded room, and someone yells fire, and there's only one exit.
Okay.
Everybody will rush to that exit, and it'll all be a focused beam coming out of people. That's exactly what happens. The thing is spinning so fast that the only way out of it in the magnetic field is at the poles.
Okay. Fantastic.
but it's not one exit, it's two opposites, right?
Yes, that's true.
Yeah.
And it goes that fast. Well, they can't be that large to go that fast, or the edges would be going faster than the speed of light. If it were,
Yeah, that's in the theory. Let me find this thing here.
I mean, some of these suckers go what, hundreds of times a second?
Yep.
Good Lord.
It's kind of neat these programs because I don't know all this stuff, and so when they come up, this is like better than Star Trek.
Well, have you finished your Alex Filippenko video lessons, Tim?
Oh no,
Oh,
there's so many of those. God, he had I guess he did all those videos at a time that he was really busy, so he wasn't getting very much sleep. I mean, there's a ton of them. Go ahead, Jerry.
got us fascinated here.
Yeah.
Why the Black Widow, though? Is it just nasty, one of the worst?
Oh, look at that. There you
I
go.
guess.
Now, this is a neutron star that is a pulsar. And this is what this pulsar happens to line up. One of them lines up with us and the other one doesn't. But if it's really close, that would be very bad news for us. But we get this burst of X-rays and high energy particles from it when it zips around.
Well, if somehow from that distance our Earth was to be caught in one of those beams, it would be very fast, wouldn't it? It wouldn't be on us long. You suppose it would be
a
enough to
fast radio burst. There's an acronym for that, but
as far as
FSB or something.
FRB for fast radio burst.
Yeah, that's it. Yeah, thanks.
FRBs.
For me to talk and think at the same time is quite a challenge.
You do really well.
You could be a Brighta Hall professor, Jerry. No question. Fascinating.
Okay.
Well, we got a quarter of the hour to go, and you got through all the talking points.
Not yet.
Oh, okay.
So a lot of this I didn't see in the talking points. These are things you're bringing up, some of the images.
Well, there are links under the images that if you click on, you get these GI.
Oh, no wonder. No wonder. I don't bother. I'm just reading.
I have to click on them and then load them into the thing.
Still got Pan stars to talk about, right? The comet.
Maybe.
There's a great video on spaceweather.com today of Pan stars in the view of the SOHO, I think it is, or SDO. And you see it coming in. You know, we can't see it from Earth with regular telescopes, but the solar observing telescope can see it, and you see it come in, and it actually interacts with one of those coronal holes where there's a flow coming out.
Yeah.
As you see it get around the sun, you can see the ion tail swing around and point away from the sun. As
Oh,
the dust tail still stays in
Yes.
the old orbit. So it's a pretty neat little video.
Now, this is an X-ray picture taken with an X-ray telescope of the Crab Nebula pulsar. In the middle of the Crab Nebula, there is a pulsar, and this is the pulsar pulsing. And it looks like this is about real time.
Well, it does 33 times a second, so I think this is slowed down.
I think you're right.
Wow.
Okay.
So one of those beams is hitting us directly to be able to see it pulse?
Yeah.
Yes. And it's a good long distance away, so we're not terribly worried about it.
yeah, but I was going to ask you, I don't think I will, maybe another time, with why if they were closer to us, it's deadly, but if they're far away, it's
Well,
not so much.
1
Yeah.
over r squared.
Yep.
The beams,
Distance is our friend.
but
Okay.
the beams are cone shaped, so they spread out, right? And by the time
Yes.
they reach our distance,
They're pretty wide.
Okay,
Yeah.
that's the answer.
But still, to have
Diluted.
them sweep by 33 times a second is quite a deal.
ooh,
So this is a drawing of the magnetic field lines from the neutron star, and it can get out without getting, if it comes out somewhere else, it's going to get wrapped into one of these field lines, and we're not going to see it. So these jets come out at the poles, and this one is rotating. I don't know what this purple line goes in front, so it's rotating from here around the front and then going back over there.
Yep,
And that's
yep.
why these in the back are getting faded.
but sometimes don't they wobble as well?
Well, no, see,
go
this is the rotation axis of the neutron star. But you
Oh.
notice the beam does not
Okay,
come
that
out
makes-
there.
There you go. I'm sorry. That makes the wobble.
Yeah.
That beam's going around the green.
Mhm.
Wow.
Someone-
Don't some black holes do a similar beam thing on its poles?
Yes.
Yeah.
Is
That
it
tends to come out of their rotational axis.
is it a totally different concept or is it similar?
It's
It's
similar.
similar.
Yeah.
black
Ron,
holes
it's often called the lighthouse effect.
Is it?
I didn't realize that there's a rotational axis that's different than the axis
yeah.
of the magnetic field lines.
Yeah,
Yeah.
that's right.
More likely than not, Tim, they're not co-aligned.
Yeah.
That's kind of like what's happening on our Earth, right?
Yeah. Our
Mhm.
rotational axis does not correspond with our North Pole.
Right.
So a guy came one time a couple of years ago and gave a lecture on these pulsars. And he had a big ball of styrofoam and he stuck a flashlight in the ball and then he rotated the ball in his hands. So the flashlight was not on the axis. And he said, this is a pulsar.
Yeah.
Mm.
But have they found any where the same axis, the green one, is the same as the violet beam?
I don't know about that. I don't
But
know
then-
how you would find one because it's beamed at us constantly.
Yeah, it wouldn't flash.
That's
I
right.
know that, but anything caught in those beams, they don't have a chance, do they?
If you're close enough, that's right.
Oh,
Because
you're
it-
right. It wouldn't flash. So we wouldn't know.
Well, we'd see a bright source.
Yeah.
But these things don't have planets going around them, exoplanets.
Yes,
They
they
might.
do.
Do
The
they?
first
nothing-
exoplanets found were around a pulsar.
Yeah.
No kidding. Wonder what life is like for those extraterrestrials.
Not cozy.
Sunrise is very dramatic.
Okay, what are we looking at here?
This
This
is
is
the
the
Crab
Crab Nebula.
pulsar,
Crab.
Crab Nebula. You can see shock waves going out here.
Wow.
I
And
thought the crab was
beams-
more scattered, and
The what?
This is the central region.
I've
Right.
seen crab nebula. It looks like an omelet I've tried to make in a pan.
That's at our visible wavelengths. These
Right.
are
Oh,
not.
okay, got it.
Yeah, it looks like a splash of milk in the visible.
Exactly right.
Yeah,
And there's
then
a great video of this going where the whole thing is going like this, with the pulsar.
Yeah.
Yeah. Well, it's sure lit
the
up.
backyard telescope, Ronnie, it's just a smudge.
You
can
can't
ba-
see
you can
gamma rays.
barely see it.
Oh.
Right.
This astronomy is so colorful. Look at this.
So
Okay.
this is the location of the known pulsars. I think there's 30 or something of them. I think it says in the
And they're using this as a standard for navigation now, because a lot of things were Earth-based and they vary as the Earth poles wander around.
yeah.
If you want to do long distance space travel, you can use these pulsars and actually even black holes, quasars, as like your GPS system.
Signposts.
Yeah.
These are the
On the,
lighthouses, aren't they? The
Yeah.
lighthouses.
on the plaque that we put on one of the Voyagers, it
Right.
shows the distance, the orientation to each of these pulsars on the plaque so that you can locate where Earth is.
And it
Hmm.
shows their pulse pattern too to help people identify the orientation.
Right. And many people since then have claimed that this is a bad idea.
Yeah.
Oh, it was Carl
Yeah.
Hawking,
It was
Hawking for one says, don't give it away.
Yeah, so this is the 16 most recently discovered pulsars.
Yeah.
This is the famous Vela pulsar.
Well, Gary, forgive me for possibly missing an explanation earlier about these. Is this one of the options for the ending of a star? Yeah, it could become a black hole or a neutron star or just a nova or one of these.
Yeah,
Well, a pulsar is a neutron star.
yeah.
I know, but is it always a neutron star, or did it start out like a sun or a Betelgeuse or?
Oh, no, to get a neutron star, you have to have a sun. You have to have a star.
Okay,
And then it
so it is
reaches
an
the end of
ending.
its hydrogen burning life and goes supernova, and you get a neutron star, and then that can be a pulsar or not a pulsar.
Yeah, when a regular star collapses for whatever reason, as it collapses, it speeds up. And if it collapses to a neutron star, it way speeds up. And when it speeds up, the charge in the star can produce extremely large magnetic fields. And then you can get a pulsar.
Our sun could become one.
No, our sun
no.
end up as a white dwarf.
Yeah,
We don't have that kind of mass, Ron.
yeah.
Well, what happens to pulsars in the end?
They spin down over time.
They don't
Yeah,
become
they're
a black
giving off
hole.
radiation, and it takes energy away to give that off.
Okay,
So
So
like
they don't-
even black holes will disappear because they're giving off Hawking radiation. It's very faint, it's very slow. This shows the Black Widow pulsar, and it shows its shock wave, its bow wave in space. Now, a Black Widow black hole is a black hole that, like the one we saw earlier, not a black hole,
Pulsar.
neutron star. Yeah,
pulsar.
a pulsar. We saw earlier that the one star was giving off matter to the other one, but a pulsar has a small companion to it, and the pulse comes around and it hits that small object that's oriented it destroys it over time, and that's where the Black Widow pulsar comes from. It's eating its own young.
Huh.
This is a picture or a diagram of the Black Widow pulsar's shock wave. And this is a very big scale. And that's what you saw was just before was an actual picture of the shock wave, the bow shock. This is an artist's rendition of what's happening in the bow shock.
It's moving.
Yes.
Yes, it's moving through the interstellar medium the same way as,
The heliosphere.
yeah. I thought I had it in here somewhere.
Yep.
Oh, there it was.
Went by it, yeah.
The same way that the sun's heliosphere is producing a bow shock in the interstellar medium.
Because we're moving.
So this, all this radiation coming out of it is pushing everything aside. And this is what that looks like in an artist. And then really close in is the Black Widow pulsar. and this is the object that's surrounding it. It's not as dense as this one. It can be bigger. When I said it's a smaller companion, I meant it was less dense. And it's got its own shock wave from material trying to get off this guy. And every time the beam hits it, it blows material off this way into a tail like a comet. And eventually it's going to get used up. And so that's a black hole pulse, a black widow pulsar.
But those two aren't moving toward the left.
They
Not necessarily.
those two here are moving to the right. So, and the scale is very, very different. This scale here is millions of times bigger than that scale. So in this white dot are these two objects.
Wow.
So this one, they are in the previous one, they're all moving to the right, but this one is getting all its dynamics from the radiation coming off this guy. So that doesn't imply the motion of this guy.
Okay.
But Jerry, the picture you showed us earlier of the solar system, the sun's bow shock, would that include inside it the Kuiper belt, the Oort
Yes.
cloud?
Yes.
Everything
yes.
is within that. It's not out
Yes.
past that, is it? It's really big. It's what you're saying.
Yes, it's really
There's some-
big. What the one of our Voyagers passed the shock wave.
Did it really?
Yeah. See, this shows them the Voyager probes. This is
Well-
the relative position at the bow shock going into that.
They've passed the heliosphere.
Yeah, that's
I don't think they've reached the bow shock yet.
okay. Yeah, they haven't. Yes.
Another plasma question for you, Jerry. You said the BioShock was low density plasma.
Yes.
So the temperature of that it's not very large.
The
I think
temperature
you showed
would
us
be
this
high,
stuff.
but the amount it would transfer to you if you stuck your hand in it may be small.
Yeah, I think Jerry said this once before that it's not dense.
It's like the corona of the sun.
Yeah.
Do they know when it's going to pass? When they're going to go through it?
It's a long time.
They're hoping to get it. They just shut down a second instrument on one of the Voyagers so that they can continue measuring the particle count to see when they go through the bow shock, hit the bow shock.
Just a little tidbit for you, Ron. So the sun there that you see dragging all of us in the solar system off to the
Right.
left, it's on its way to kind of the keystone of Hercules. Isn't that cool?
Oh,
It's called the solar apex.
Well, is it close to Proxima? Is it halfway to Proxima Centauri? Or is it just
This is not a light year away.
oh, it's not
Right.
quite.
This is I think it's a light week or a light month or something away at the most.
Yeah, sounds
So
right.
it's still got the Oort cloud out here.
But chances are the Alpha Centauri system has its own bow shock. I wonder if it's pointed the
Yep,
same way.
Yep.
Well, it probably shares much of our motion around the galaxy. So yeah.
Mm-hmm.
The heliosphere. Is there something actually there at the edge that is matter or gas?
That's where the solar wind finally decelerates.
Yeah.
Okay, gotcha. And all stars have that.
Yeah. So Ron, it's always fun, when we're doing especially, summertime outreach, just point up at the keystone of Hercules and say, that's where we're headed.
Yeah.
I
Keystone,
didn't know that, Tom.
Is that cool?
Does it look like a keystone on an arch?
Yeah. Yeah.
It does. That's why they call it that.
Yeah.
We finally know what that means.
Yeah.
Is
And that was
Trapezoid.
Herschel. That was William Herschel that figured that out.
Yeah.
that right?
And that's where that big globular M13 is.
13's there, 92's there too. Don't forget.
92. Yeah.
Everybody
The
skips
other
up
globular.
92 and it's wonderful. Yeah.
Yeah, we'll have to check that one out, Tommy.
Oh yeah, it's really nice. Yeah. I forget where the anapex is. Chuck, do you happen to know where we're
No.
going away from in the sky? Yeah.
We're going back in time real fast. What is
That kind of stuff is in my old books.
Yeah.
Yeah.
Just turn around, face the other way.
That's it. That's right.
Oh, here's some of that Soho imagery.
Wow.
Yes, SOHO imagery for comet Pan-STARRS. This was before it passed the sun. It's now past the sun. It survived. It's doing well.
Wow.
And it's now visible in the southern hemisphere only. So I debated whether we put it on or not.
Well, when in the space weather video, when you see it go by this plume that's coming out at about 5 o'clock,
Yeah.
it really reacts to that, and then as it continues on, you can see it start to develop the ion tail swinging around. It's
Wow.
pretty cool. They
Well,
titled it "Birth of a Unicorn" because it looks like a horn coming out the front of it.
Wow.
why is its tail not pointing to the right, straight away from the sun?
Because that's the dust tail.
It's dust.
That's different.
And it'll show some curvature because it does have mass, Ron.
Yeah.
So that tail is in its track. It's where
Yes.
it's been.
Mhm.
Yes.
I'll be damned. And what
With
is the
some drift.
zero? What's the zero in the center of the filter? And what is it?
That's the size of the sun, but
Oh, got
but
it.
showing how it's blocked out.
Right.
Has our Parker probe been sending us anything?
I'm sure.
I mean, it
Not
comes
anything
down.
that's made the news.
Yeah.
Imagine it's an incredibly oversaturated light source.
Yeah.
Okay, well, I just lost the ability to show, but you can hear me.
Yeah.
Yeah, we can hear you, Jerry.
Yeah.
Well, are you done?
It's
Yeah.
also, it's noon right now, I think.
Yeah.
Yeah. Well, look, gentlemen, we'll see you Friday night in the big auditorium on the campus for a lady named Freeman, Abigail Freeman, going to take us on to Mars for Curiosity, and we'll be back next week for the
Okay.
first May week version of the Astro Hour. In the meantime, here's how we say goodbye in astronomy terms, right?
Asta Nebula.
Great show, Jerry. Great show.
Thanks,
Do widzenia.
everybody.
Do widzenia.
Dive, take her down to 300 feet. One at a time.
Mm, mm, mm.